One of the purposes for empirical formulas is to figure out the chemical or the molecular formula of the compound from the empirical formula. Please remember, sometimes we interchangeably use the terms chemical formula and molecular formula. They really mean the same thing. Molecular formula is more specific to a molecular compound, whereas chemical formula is more general for any compound. So, as I said, one of the primary use of empirical formulas is to determine the chemical formula or the molecular formula. So for ionic compounds, please do remember, as we said before, that chemical formulas are the same as the empirical formula, because both of these formulas give us the exact same information. So for the ionic compounds, the two are exactly the same, but for molecular compounds, they may or may not be the same. Now, in order for us to determine the molecular formula of a molecular compound from its empirical formula, we have to first figure out the empirical formula and then multiply the empirical formula by a certain number n. This n, the value n, is a whole number. It's an integer value. It can never be fraction value. Now the n is a ratio that is obtained, that can be calculated by dividing the formula mass or the molar mass of the compound by the empirical formula mass or the empirical molar mass that you determine, in such a way that the units cross out of each other, so that the units of the denominator will either be AMU if you're working with formula mass, or the units will be grams if you're working with molar mass, so that the value n has no units. It's a unitless ratio. Please do remember that the value n is a whole number ratio. Now you do need to memorize this thing, how the method used to convert empirical formula to molecular formula. Please memorize this. Okay, let's use this to do a very simple problem. For example, the empirical formula of a compound is given and its molar mass is given. We are asked to figure out the molecular formula of the compound. Now once again, remember, the molecular formula of a compound can be determined from the empirical formula by multiplying the empirical formula by a integer value n. n is calculated by dividing, in this case, since molar mass is given, molar mass of the compound by empirical molar mass. How do I figure out the empirical molar mass? It's not given to me. Exactly. The empirical molar mass can be calculated from the empirical formula. So the molar mass of the compound, of course, is given as 180, and please note that decimal point for sig fig purposes, grams per mole. This is given, but the empirical molar mass can be calculated from the empirical formula by adding the molar masses of all the elements in there. Same units as the numerator, so that the units cross out. When you do this, the whole number that comes out to be, when you divide the numerator by the denominator, we get 5.994, which of course has to be rounded to a whole number 6. Once you have that, molecular formula is the empirical formula multiplied by this number 6, which gives us C6H12O6 as the answer. Okay, now this was just a guideline to show you how to use this information, but your problems that you'll see will be more of this kind, where you have to do the entire process. In other words, here is an example of methyl benzoate. We are given its formula mass and we are given its percent composition, and we need to calculate the molecular formula. Now, there are two different ways of doing this problem. Both of those ways are absolutely correct. One of them, of course, requires you to calculate the empirical formula first. So let's do that. As we did this before, please pause the recording at this time since we've done a similar problem before. Pause the recording, do it on your own, and then come back and check your work. So we know that the compound has C, H, and O. We know the percent composition of carbon is 70.57. Percent composition is always by mass. 5.93% hydrogen by mass and 23.49% oxygen by mass. So if that is mass percent, we can assume that we have 100 grams of the sample, which means then that sample will have 70.57 grams of carbon, 5.93 grams of hydrogen, and 23.49 grams of oxygen. Once you have mass, you can figure out the moles of each element using the molar mass of each element. After rounding to the appropriate number of significant figures, we get 5.876 moles of carbon, 5.87 moles of hydrogen, and 1.468 moles of oxygen. Once you have that, you can then divide each of the moles by the smallest value to figure out the ratio of moles in whole numbers. So after rounding to the closest whole number, we get a ratio of 4 carbon, 4 hydrogen, and 1 oxygen, such that the empirical formula of this compound is C4H4O. But we are not done yet. From here, we can determine the value of N, which remember is a ratio of the formula mass that is given 136 AMU and the empirical formula mass that comes from the empirical formula. In this case, the empirical formula mass will be 4 times 12.01 plus 4 times 1.01 plus 16.00. It comes out to be 68.08 AMU, and when you divide the two and round, we get 1.9976, which rounded to a whole number gives us 2. Therefore, the molecular formula of this compound methyl benzoate is C4H4O multiplied by the number 2. That gives us C8H8O2 as the final answer. Now, as I said before, there are two different ways in which to solve this problem correctly. One of them is shown right here. Why don't you try and figure out the second way in which you can also solve this problem, and you can either email me or come talk to me and show me your work, and I'll be more than happy to go over that with you. Okay, so here's another problem using the same idea. In this case, we are given the molar mass of the compound. And upon decomposition, we know that this compound is made up of C and H and O. We know that this compound has 5.87 grams of carbon. We know it contains 5.91 times 10 raised to 23 atoms. Please be very careful. Atoms of hydrogen. Oxygen, of course, we are not given grams or particles. Instead, we are given moles. We are given that there are 0.490 moles of oxygen. Now remember from before, empirical formula needs moles of all the elements, so we can convert 5.87 grams of carbon into moles of carbon using molar mass of carbon, which gives us in 3 significant figures 4.89 moles of carbon. We know atoms of hydrogen. Can we convert atoms of hydrogen to moles of hydrogen? Absolutely we can, using the Avogadro's number this time. So when you do that conversion in 3 significant figures, that comes out to be 0.981 moles of hydrogen, and of course moles of oxygen was given. Once we know the moles of oxygen, once we know the moles of all the elements, we can now figure out the lowest whole number ratio by dividing each of these moles by the smallest. So we get 1 is to 2 is to 1. That means that the empirical formula for this compound is CH2O, and the value of N therefore will be the molar mass that is given as 60.1 grams per mole divided by the empirical molar mass. Empirical molar mass will come from the empirical formula: 1 carbon, 2 hydrogens, and 1 oxygen. Same units as the numerator, because please remember this ratio, N has no units. When you calculate this and round it to the closest whole number, we get a value of 2, and therefore the molecular formula for this compound equals the empirical formula times this number N, and that equals C2H4O2. The compound, whatever the name of this compound is, the actual compound is made up of, or the molecule of the actual compound is made up of 2 carbons, 4 hydrogens, and 2 oxygen atoms.